Hello guys, welcome back to the reaction zone. In today's lesson, we're going to solve the question on the board using stoichiometry. And the question is as follows. Calculate the volume of CO2 at standard temperature and pressure evolved by strong heating of 20 grams of calcium carbonate. To solve this question, we need to find the molar mass of calcium carbonate. The molar mass of calcium is 40, for carbon is 12, there are 3 oxygen atoms, that is 16 times 3. And everything here is going to be equal to 100 grams. The molar mass of CO2 is 12 for carbon plus 16 for oxygen, but there are 2 oxygen atoms, that will be 16 times 2. And everything here is what? 44 grams. Also, what we have here in terms of moles is 1 mole of calcium carbonate and 1 mole of CO2. So, what is here is also the same thing as 1 mole of CO2. CO2 is a gas, and the volume of 1 mole of any gas at standard temperature and pressure is 22.4 liters. Now we're going to calculate the volume of CO2 at STP that is evolved by strongly heating 20 grams of calcium carbonate. So, from the balanced equation, now that we've determined the molar mass of calcium carbonate and we have determined the volume of CO2 in the question based on the number of moles, we can infer that 100 grams of calcium carbonate liberates 22.4 liters of CO2. So 100 grams of calcium carbonate liberates or evolves 22.4 liters of CO2. But the question is telling us to find the volume of CO2 at standard temperature and pressure that is evolved by heating 20 grams of calcium carbonate. So we'd say if 20 grams of calcium carbonate liberates X liters of CO2, if you cross multiply, that's going to be X times 100 is going to be equal to 20 times 22.4, and X in this case will be 20 times 22.4 divided by 100. 20 will go here 1, 20 will go here 5, and this is going to give us 4.48 liters. So this means that the volume of CO2 liberated at STP by 20 grams of calcium carbonate is equal to 4.48 liters. Thank you for viewing, and see you in the next lesson.